Okay, we are live. Hello, everyone. Welcome to the second episode of Observability Unplugged. Super excited to have you all here. My name is Kunal. I'm working as a DevRel engineer at Randoli. And in this particular one, we are going to talk all about how you can monitor Kafka with OpenTelemetry. So, we are going to discuss how you can instrument Kafka using OpenTelemetry. And we'll also have a nice light conversation around what are some real world use cases and what are some metrics that you can track in production if you're using Apache Kafka in production, right? So this is the topic for the second episode, and I'm super excited to have two very special people from the Randoli team, Shrimal and Isha. Hey Shrimal, hey Isha, how's it going for all of you?
Hi, Kunal. All good here.
Amazing, yeah. Super happy to have you both here. I think let's start with a quick round of introductions, right? Shrimal, why don't you start? Would love to know a little bit about your experience. If you can share what are you up to these days and what is it that brought you into tech? If you can share a bit more about that.
Yeah. So let me answer the your last question first. Uh, tech is my passion. Like I'm quite interested. Like dealing with this stuff. This is something that I really enjoy. So that's why I'm in tech. So I initially started working in a small company, and uh, quite a small company, and then uh, I got my career into a path where some systems that were running in massive scale, heavily reliant on Apache Kafka and some modern languages like Golang. And then I joined Randoli, and here I have a set of different challenges. Uh, yeah, I mean, the work that I'm doing here, quite interesting, because it helps other people to like other developers to like run their systems healthy uh, in production. So that's what I really enjoy.
Amazing. Yeah. Thank you so much for sharing. And by the way, for audience who's watching, Shrimal has a lot of interesting experience and production experience with especially with Kafka, working with Kafka in his previous companies. So it will be a really nice conversation to have with him today to learn more about what actually might go wrong and how to actually track things with Kafka. So it will be really interesting. Thank you so much for taking your time, Shrimal, for this one. Isha, why don't you introduce yourself? Tell us a bit more about who are you? What are you up to these days?
First of all, thank you, Kunal, for having these discussions. It's really very thoughtful of you. Basically, I just joined randomly as an intern, and I'm usually working on the technical documentation stuff right now. But apart from that, I have also configured few of the things. Like one of the recent things that we are going to discuss today is about the Kafka one. I have written a documentation about it, have some research on it, and apart from that, I'm usually a hardcore DevOps person and being into like the CI/CD stuff. So yeah, I'm pretty much excited for today, and yeah, it's going to be good.
Awesome. Yeah. Isha has, as she mentioned, she's recently joined our team and she has been working on some amazing stuff related to, she has written some amazing articles related to Kafka and it's very much related to the topics we are going to discuss today. So we have Isha who has just recently, very freshly worked on Kafka and trying to understand what Kafka is, how you can instrument it. And we have Shrimal who has a lot of experience and production experience with Kafka. So you can see we have some set of diverse experience in the panel today and I think the conversation is going to be really good. So let's start, right? Without further ado, for people who are watching, I see that we have around 10, 11 people who are watching. I would suggest if you can quickly drop in the chat from where you are joining from. We would love to hear from you, and if you have any questions during the session you can just drop it in the chat and we'll love to take those questions related to this particular topic. But Shrimal, let's start by building some context, right? For folks who are watching this, some of them may be familiar with Kafka, maybe using them in production, right? Some of them may not be, and this might be their first time learning about getting started with monitoring Kafka, right? So, could you start us off by giving a quick primer on what exactly is Kafka, right? and how teams are actually using it in production, and sort of why is it important to monitor in the first place? If we can start with that.
Oh, yeah, yeah. So let me start from thinking about a very small system which uses like HTTP to communicate among microservices. Like every system like start in that way, right? We build something in a very like simple way, and heavily relying on HTTP. But what happens when we need to run it in a scale? When the traffic increases, uh, there is there are some limitations come up. Uh, One limitation is that HTTP is synchronous. Like uh, one service makes a call, some other service has to respond, and like when we deal with thousands of requests like starts to pile up, and it makes those applications uh, failed, right? So uh, then we need to make those communications asynchronous in order to solve that problem. I think that's where Kafka comes into the uh, game, because it supports asynchronous communications, and it acts as the distributed event bus in the system. So that's where Kafka comes into the game. It makes those systems, like scales better, and it allows us to communicate asynchronously.
Interesting. Sure. Asynchronous communication is what makes Kafka different, right? But
Yeah.
how actually teams are using it in production right now? Do you have any particular use case that you can share from your experience? One particular use case, maybe that could help people relate to. Okay, this is where Kafka is being used. This is interesting.
Yeah. So let's say like as an example, you're writing something to send an email out, right? So user clicks on a button that triggers something in the backend which sends an email out. So the traditional flow is that user clicks on a button that makes an HTTP call to the backend, and backend service involves, and it calls the SMS email service and sends that email out. So the flow is synchronous, and customer like whenever something wrong goes in the email service, uh, the customer won't be able to like send that email out. So we won't be able to receive that email, because when we lost that transaction, we lost it forever. We don't keep it. So when we thinking about a streaming way of solving that problem, what we do is that whenever a user clicks on that button, that publishes an event. Let's say an event called send email. So there's a Kafka consumer. That email service is relying on Kafka and consumes from a topic. So whenever it consumes that message, uh, it sends that email out. So the communication is asynchronous there, and it scales better. Let's say like we had the email service not working for some time. Let's say like it was offline for 10 minutes. And whenever we get that service back up and running, it can recover that previous messages and send those emails out. I mean, that's how Kafka solves that problem.
It's pretty
So
interesting.
in a
Yeah.
way, I would
I've
say, yes. So
Sorry. Go ahead.
in a way, yeah, in a way, I'd say that Kafka is a kind of like distributed commit log, because it keeps all those messages in the file system, and consumers can recover them later. So if you think about other communication protocols like ActiveMQ, RabbitMQ, they don't have those capabilities. And if they have, those capabilities are very limited. But Apache Kafka provides us that retention. It can keep messages.
Gotcha. That makes total sense. This is very insightful. I have recently started learning about Kafka, and you mentioned about RabbitMQ as well, right? So there have been a lot of I'm reading a lot of articles on comparing between these two, RabbitMQ and Apache Kafka, and I think the example that you gave is really relatable, right? It shows sort of the two main things that you mentioned was Kafka is really good with asynchronous communication, right? And it scales better, right, as compared to its other counterparts, right? That's interesting. So I think now we have got some context related to Kafka. Right? We'll be having a bit more conversation around monitoring Kafka later on, right? But for today's session, so when we talk about Kafka, right, when we talk about monitoring Kafka, just to give everyone a bit context, we talk about client side and server side. So Kafka has two separate sides. One is a client side, which is, as Shrimal mentioned, the producer and the consumer, right? And there is the server side, which is the Kafka broker, right? Uh,
Yeah.
Client side instrumentation is a bit different. It involves the OpenTelemetry SDK, right? We will not go into that in this particular session because that's a separate topic. In today's one, we'll be focusing on how you can specifically instrument the Kafka broker, which is the server side of Kafka, right? And why is it important to do that? What is it? We'll definitely touch more upon that in the later conversation. But uh, right now we'll focus on the Kafka brokers, how you can start getting some important metrics out of the Kafka brokers that you have using OpenTelemetry. So Isha, I know you have been learning a lot about this recently, right? You have written two interesting blogs which you'll be sharing as well in today's episode. But let's start from the top, right? um, I've been reading your blogs, right? And you mentioned that there are different ways to collect Kafka broker metrics using OpenTelemetry, right? So if you can walk us through what are these different ways, what options do people have, right? And which of the one are we going to focus on today and why, like what's the main difference between all of these three? If you can walk us through that.
Yeah, surely that's a very nice question to be honest. Like, firstly, for that I need to share my screen. I just prepared a diagram for the audience so like they will be able to clearly see like what I'm going to talk about. Just a second.
Sure.
I guess you're able to see it now, right?
I Yes, now we are able to see. For the viewers who are watching, let us know if Isha needs to zoom in a bit. Isha, maybe you can zoom in a bit so that people can see clearly.
Yeah, sure. Is it okay now?
Yeah, I think it should be okay in my opinion. People in the chat, let us know. I'm not able to tell from here that whether you're able to see, but let us know if you're able to see it clearly. Yeah, Isha, go ahead, please.
All right, so I just divided this whole like the first question that you asked me about the three ways and all of that. Before that, I just want people to see, as you said, like we have two ways. Like we have like in this diagram, this the above diagram usually depicts about us. Like we have like the consumer side, as you can see, like we have the producers app and the consumer app, and then we have a like separate thing which is called the Kafka server, which have the Kafka brokers one. In that, this usually gives you a proper setup like what the Kafka monitoring, how it actually does from both the client side as well as from the server side. And here, like as you said, like in this live chat, we just gonna focus on the Kafka monitoring stuff from the server side, which exposes the matrices via the open telemetry collector using various receivers and the analysis, which will I walk through with the second diagram. So let's start. Now the first thing that I want to like tell to people who are in the chat or like who are not familiar with this, the first thing is that in the open telemetry collector, the component which is responsible for gathering the data is called a receiver, right? I have mentioned here the receiver. And when we like talk specifically about the Kafka, there are mainly three ways, or should I say the three methods through which we can scrape the matrices. What are those methods? The first one is the JMX receiver, the second one is the OTL Java agent, and the third one is the Kafka metrics receiver. Now, if I walk you through all the three methods, just a short info, like for short brief about this, the JMX receiver, what it does, it's like connects to the Kafka. It just connects to the Kafka Java management extension. The first thing it does is to connect with the JMX port, and then it will scrape the M beans directly from the Kafka Proker's JVM. here, but here's the case for the OTL agent one. It doesn't connects with the JMX stuff. A Java agent will get attached to the Kafka process that auto instruments the JVM and exports the matrices and traces via the OTLP protocol we have to the collector. And the third one that we are having is, you can see here, the Kafka metrics receiver. It uses the Kafka admin client and the consumer APIs to pull the broker matrices and whatever matrices we have, like that, and without depending on the JMX. So the short example I can walk you through is like, consider the JMX here, the JVM one as a manager of a factory. Now the JMX, what it will do, it directly talks with the manager of the factory to get all the details of the performance updates. You can get everything into it, but for that you need to be to have the SS inside. The Java OpenTelemetry agent will act like placing an assistant inside the factory who will automatically tracks and reports all the activities without you need to asking it about each time. And the Kafka metrics receiver is like checking like a, you have a public dashboard outside the factory. You will only get the main numbers, like how many, like we have the like how many products we have shipped, how many products will be there, but will not get the full in detail. So the flow usually goes like in Kafka brokers, we have three methods. As I said you, the JMX receiver one, the OTL agent one, or you can use the Kafka metrics receiver based on your environment and all of that. Then you will give all the either one you can use either of the method. Then while the OTLP port, OTLP receivers and all of that, you will have your matrices, and with your preferred background, you will able to see or visualize that. Now here's the case, like for each of these methods, you need some of the configurations. Like for the JMX receiver, I guess, you need to enable the Kafka JMX port in your Kafka container or your instance, and you need to add a JMX section, which I'll show you through the hands-on stuff in your OpenTelemetry collector file. And with that, we will having some target system as Kafka and the endpoints. For the Java OTL agent one, you need to attach the OpenTelemetry Java agent jar file to your Kafka instance, as well as you need to define your OTLP endpoints. And for the Kafka metrics receiver, you need to provide the brokers and the protocol versions, and there won't be any specifically JMX setup required because it connects directly to your Kafka APIs. So I guess I'm able to give a brief introduction about all these ones. And here's the main case, like where you're using it. So if it totally depends on your use case and all of that. If you're using the JMX receiver, you need to get, if you want to get a detailed JMX and broker level visibility, I should say you go with the JMX receiver one. If you need to push through the OTL collector, you need to push through the matrices to the OTL collector instead of exposing them through the external JMX port, then I said you should go with the OTL Java agent one. And if you just want the fastest way to get the most lightweight and the setup, you don't need to go deep down into the matrices and JVM level details, then I guess it would be better to go with the the Kafka metrics receiver method. This is the major difference between them, when to use it, why to use it. So yeah, if I'm able to give you answer correctly.
That's pretty interesting. Yeah, that was the next question which came into my mind, right? That we have these three different methods, which one to choose when, right? So I
Yeah.
think you answered it really well, and I think this is something that you have also mentioned in your blog that you have recently written. So for anyone who wishes to learn more about these three different methods of monitoring, right? What's the configuration needed, and what's the major difference, and when to use what according to your use case, I have just dropped the link to the blog post in the comment section, so you can definitely check it out. But I think, Isha, it would be unfair if we just talk about things and don't show anything, right? So
Yeah.
as you mentioned, right, we are going to today learn a bit about how to configure the JMX receiver. So can you show a
Yeah.
little bit about how to configure that in the OpenTelemetry config, and if you can send some metrics to Prometheus and show like how things will look, and what are the metrics that you get from the JMX receiver on the Prometheus dashboard? I think that would be really helpful.
Yeah, surely. That will be some hands-on stuff. To be honest, I'll just share the code. Just give me a sec. All right. So, before into even diving into that stuff, I just want you guys to Just one thing. I need to like conclude people like why we are using these GMX receiver stuff. Like Kunal asked, like we have three ways. As you can see in this diagram, we have GMX receiver, OTL Java agent, and Kafka metrics receiver. But we are like for this convo, we are going to have the GMX receiver one. So like why there's a need to do that? I feel like whenever you are having to monitor the Kafka into the production, like you need to monitor Kafka brokers in production, because like Kafka already exposed most of its matrices internal matrices over the GMX. So instead of adding any custom agent or modifying the code, I think it would be simply connect to the GMX port from the OpenTelemetry agent and start scraping all of those matrices. So that's why I think like choosing the GMX1 receiver right now for the conversation, it would be much better. And one more thing before it kinds of like a prerequisite, like when if you're using anything, like you're using Docker Compose or your Kubernetes deployment under the Kafka, whatever you're using, it doesn't matter. You just need to add these. The ones I'm showing you, these are actually the Kafka environment variables, like the GMX. What it actually does, this will ensure that the GMX metrics endpoint is open and accessible for the Open Telemetry collector. So here I have given introduction, like what's the breakdown of that also. Like this, usually you just need to like add these into your Kafka container or whatever you are using, like your Kubernetes deployment or your Docker Compose, whatever stuff. And what you need to do, just add these environment variables. And here you can see that we have the GMX port at 9999. And this, what it actually does, I already told you, it will make the internal Kafka matrices available through GMX. So the Open OTL collector can receive it and can export them. Now let's just jump to the code. This is actually, when I talk about the GMX approach, this is actually my OpenTelemetry collector config snippet. As you can see
Isha,
here, what I
sorry
want.
to cut you. Can you please zoom in a bit to the code so that people can see clearly?
Yeah, sure. Is it now good?
Yeah, I think now it should be good. Thank you.
All right. So, all right. So let's just walk through this. There's nothing like too complex in this. I just took a short example. What I did is like, if you can see here, we are having this jar path. What you need to do, this is the path to the Open Telemetry JMX metrics jar file. What it does, it actually acts like a bridge that knows how to scrape the M beans, as I told you, the M beans from the Kafka brokers, JVM. Think of it like the collector plugins. Think of it like a collector plugin that understand how to talk to Kafka internal matrices structure. After that, we will have our particular endpoints, whatever you are using. You need to just define your JMX endpoint where the Kafka is exposing the matrices that matches the port defined in your whatever setup you will be having. Okay, and after that, in the target system, which specifies like which service we are targeting. Here we are targeting around the Kafka one. For the collection interval, it usually defines how often the collector should scrape the matrices. All right, and for the processor's name and all of that. Now, if we go to the for this example, once the matrices are like collected, they need to be sent somewhere, right? So for that, here I'll be using the Prometheus exporter, which exposes the matrices on the port like 9464, and the Prometheus will scrape those matrices. So this is the exporter section, as you can see, where I have defined the Prometheus and the endpoint for it. And now if we go to the service section, in particular service section, we are defining a pipeline actually that connects the JMX receiver to the Prometheus exporter. So the flows usually goes like from the Kafka JMX, then we have the OpenTelemetry collector, JMX receiver, then to the Prometheus one, or to your preferred backend. You can see I have defined my receivers part. Now you don't need to do anything. So this setup usually will allow you to monitor the Kafka broker matrices like messages rate, replication lag, and total bytes processed, all without touching the code. This is the major part here. Also, I would like to pinpoint one thing. If you need to like have multiple brokers into it, you can easily configure that also, and the collector using that, and you need to define that also in the same format. I have an example of that also. If you can see, here's the code for that. If you're having like multiple brokers, okay, and you can easily configure the collector using the separate JMX receiver for each of the broker like this way. This setup will also will ensures that every broker GMX metrics are individually scraped and reported, giving you a complete and distributed view of your Kafka cluster performance under the OpenTelemetry. Now you just need to do anything. You just need to run this if I if you want, I can run this like.
So in the timing, Isha is running the code. I've just dropped the link to the blog, by the way, for anyone to check it out. And if anyone in the audience is wondering, hey, why are we using OpenTelemetry in the first place? What is OpenTelemetry in the first place, right? So me and Rajat had a nice chat around OpenTelemetry. What exactly is that in one of the previous live chats? So you can definitely check it out. And interestingly, we also have a blog post written on this particular topic, which talks about what exactly is OpenTelemetry and how is it being used in industry today as an open standard in observability. So you can definitely check it out. I've just dropped the link in the chat for that as well.
All right. So the good part is this is running, thank God. And if you follow the link for the 9090 report in the Prometheus one, which will give you the all these sets, and here it is. I'll just zoom out a bit. Are you guys able to see it correctly now? All right.
Yes.
Now the magic part here is if you just type Kafka, here you can see we are having all the matrices like the controller active count, ISR, operation count total, everything. You can just pick any one and we can execute it and you can have it. Now for that, for the easier thing, I've just picked out two of the uh, I should say the matrices. The first one that I have picked out is the Kafka message count total. You can see here, and you just need to go to the execute one, this thing, and just the graph one. Just a second. Okay, it's not. There's a bit of lag. Anyways, I have another example. Uh, just give me a sec. I'm not able to see the graph.
Well, if the things don't break in a live demo, it's not a live demo at all. So
That's for sure.
that happens. No worries.
Just a sec. I'll just take any one. It doesn't matter to be honest. Well, we have the message. Yeah, we have it. Mm-hmm. I was having it before the live. No, it's not.
No worries. I
All
think
right.
what we can do is I think Isha, you really walked us through the entire process, right? And I feel
Mhm.
that for the folks who are viewing this for the first time, I hope that you would have gotten a good idea of how to set up the JMX receiver for Kafka, right, and how to get the metrics from there. If you wish to learn more, I'm no repeating this again as well. If you wish to learn more about this, if you wish to learn more about these different methods that Isha just mentioned, which is the JMX receiver, Java OTel agent, and Kafka metrics receiver, you can definitely check out this blog post to learn more about setting them up, and you can definitely try these methods out. But I would want to now take the tables towards Shrimal. So Shrimal, you've been here for the conversation. Now you've been seeing, how Isha is doing stuff. We have talked till now about um, how to get the metrics, right? We have got the metrics, and I wanted to talk with you about, now that we have got the metrics, what actually to look for, right? And some production use cases. So from a broker's perspective, because right now we are focusing a bit more on the server side, right? So from a broker's perspective, what kind of challenges have you seen teams usually run into when running Kafka in production? Let's say, maybe it could be things that impact performance. It could be related to the replication and the fault tolerance that Kafka has, right? So if you can walk us through that, I know you have a lot of production experience with Kafka. So we would love to hear some of the things that you may have also run into in your experience.
Yeah, sure. Uh, so yeah, I mean, when we run Kafka in production, the first challenge we have is that how to find that, like optimal configuration. Like we need to decide how much of partitions we are going to have for each topic, how much of replicas we are going to have, uh, like, and how are we going to retain data? I mean, what would be our data retention policy for each topic? I mean, to get that config right is quite challenging. Sometimes we need to, like run Kafka for a while in production, just to, like get an idea about, like proper values that needs to be used. Uh, so that's the first challenge, like we need to find that proper configuration. So and then the next challenge I would say auto scaling, because Kafka is not a system which supports auto scaling. I mean, there are ways to do that, but like most of the people are not doing that because they need Kafka to be super stable. So like scaling Kafka is, most of the time it's a manual process that involves, like some people to be involved, and some manual work, like setting up those configurations, taking those machines up and running, like that takes time, and mm, that takes closer monitoring as well, because adding one broker is, like sometimes it makes the cluster unstable for a while. So like we need to keep an eye on the application health as well. Uh, so that's the second challenge. And yeah, so the challenge is that, like once we get the config right, once we get, uh, like a sufficient cluster running in production, that means, like whatever number of brokers which is, like sufficient to get the load. uh, the third question is that applying upgrades, like Kafka is an ecosystem, like moves in a rapid pace, so we get, like new versions frequently, so we need to, like keep up with those new versions. So upgrading Kafka is also a challenge sometimes, because uh, Kafka is a protocol, right? I mean, uh, the broker implements a protocol, and the consumers and producer applications follows the same protocol. So when we upgrade Kafka, we need to think about, like uh, making those protocols compatible. Like whatever protocol that we have in the broker side has to be compatible with the client side as well. So before we upgrade Kafka, like we need to check the client side, like we may have Java workloads using a different protocol version. We may have some Go workloads, like Go applications using a different protocol. So we need to make sure those protocols are compatible with the new protocol that we are going to upgrade in the server side. So, I mean, those are the challenges, Kunal. I mean, but like if we pay attention to details, I think we can overcome those challenges.
It's very interesting. It's very valuable learning for me as well, right? Because specifically, you talked about auto scaling, right? You talked about having that proper configuration set up in place. But the fourth challenge you mentioned is that upgrading Kafka is another challenge, and this is something that you can only learn about if you have worked on it, right? In production. So I think that was a very valuable point that you mentioned. Thanks for sharing that. So you talked about like you when it comes to auto scaling, right? So you have to keep in mind uh the instability. You have to keep in mind how your Kafka is performing, because sometimes it might be the case that when you're operating Kafka in production, you in order to properly monitor Kafka, you are watching some handful of metrics, right, to make sure that during these operations, your Kafka cluster itself is behaving as expected and it's stable, right? So what are the top metrics that helps you to actually monitor the broker performance itself, right? And if you would suggest, if you have a list of metrics that you would suggest teams to look for and to track for the Kafka broker performance, I think that would be really helpful.
Yeah, sure. Yeah, I mean, that's the, like tricky part, right? Like once we have everything in place, we have, like a proper config in place, and Kafka is running well in production, and we have metrics available, and we do have a dashboard as well. So then, like, we need to, like think about which metrics are more important, and like which metrics are not going to be important, because I mean, we can't focus on, like hundreds of metrics at the same time, right? That's how it works. So let me take a few important metrics, Kunal. Like the first metric I would keep my eye on is offline partitions, which is super critical. Like once a partition goes offline, that means we can't consume from that partition, and we can't publish to that partition as well. So that is a critical metric. If you see the offline partition count greater than 0, that is a red signal. So we need to make immediate attention to that. Uh, so the next metric could be uh, under-replicated partitions. Under-replicated means that, like, we have a replica which is not up to date. I mean, which is not able to, like, catch up the messages data from the partition leader. So that's also a red signal, and because when we have unreplicated partition, and in case the leader goes down, we may end up having a data loss, because whatever leader has the data, that's not being replicated to the replica. So that means like we have a lag, and whenever a broker goes down, we end up having a data loss. That's why it becomes a critical metric. The third metric could be the active controller count. We need to have at least one active controller in the cluster. It cannot be 0. So if it is 0, that means we don't have an active controller in the cluster. So we don't have a coordinator in the cluster side to make that coordination. So that's also a red metric. And like there are some other metrics as well, like disk usage, like that's also critical. If it goes beyond 80%, I'd say, like we need to, like, increase, and to increase the, like, disk, we may need to, like, take that broker down. Like taking that broker down will, like, make a kind of instability in the cluster. Like we need to think about those aspects as well.
That's pretty insightful. I was just making a list while you were talking about this. So, for people who are listening in the chat, here are the things that Shrimal mentioned. Here are the list of metrics. I think the formatting was a bit gone there, but I hope you are able to understand. So it's offline partitions. We have under replicated partitions, active controller count. It cannot be 0, as Shimal mentioned, and then we have disk usage, which shouldn't be more than 80%, right? And I think Shimal, you mentioned that there are a lot more other, but I think these are the sort of something people can start with to monitor, right?
Yeah,
When it
yeah.
comes
And
to
there are some other metrics too,
Hmm.
Kunal. I mean, like, these are the, like, main metrics, but there are some other metrics as well, like, like in sync replicas, and like how frequently those in sync replicas change. Like if it changes very frequently, that means, like, we have a kind of instability in the cluster. I mean, we need to pay attention to those metrics as well, but like, these are the, like, main metrics I would keep my eye on.
Gotcha. Makes sense. So, we talked about this was specific to how you can monitor Kafka brokers performance itself, right? To keep some of the metrics to keep an eye on. But sometimes what may happen is the brokers seem fine on the surface, but there are subtle red flags that shows that something might go wrong, right? So what are the kind of metrics would you rely on to catch issues early? Let's say, things like instability or potential failures before they actually happen. And I believe you will recommend setting up alerts for these as well, right? So what are these metrics, and what are sort of the specific thresholds you would watch for to check these early signs of red flags in Kafka brokers?
Right. Yeah. I mean, like we can always, like set up alerts on the metrics that we just discussed, like those red metrics. Um, and like we need to keep an eye on the client side as well, because sometimes, like uh, client side may experience, like latencies, like lags, uh, because of some issues that we have in the server side. So I would say like we need to follow a kind of combined approach. So we need to think about server side, like and client side as well, because when it comes to Kafka, we need to treat the server side uh, as a database, like kind of a database, because uh, Kafka protocol is quite simple, and all the heavy lifting happens on the client side. So Broke acts as a kind of database, like which exposes protocol. Clients can communicate using that protocol, and uh, all the like heavy lifting happens on the client side. When you need to consume a message, client has to like request that with the offset. So server just returns the data, and even if you have a consumer group, client does the heavy lifting part, because client side implementation is implementation which handles like most of the coordination part. Server just acts as the like communication backbone, like it just provides that protocol. uh, so in that case, I would say like we need to keep an eye on those client metrics as well. Whenever we see like consumer lag is increasing, that may indicate a problem might be connected to the client, or it could be a problem in the server side as well. And latencies as well, like if you see a message produce latency is like gradually increasing in the client side, that means we have something wrong. Either it can be like on the client side or server side. Like once you have that metric in place, and once you observe that like it is increasing, then like we can take the next action, right? Like we can investigate what is happening. Like we can start it from the like client side, and then we can check those metrics available in the broker side. And yeah, I mean, we just need to like get that initial indication, like something is wrong. It could be that indication we can get it from client side or server side, but I mean it depends. Yeah.
That makes sense. And I know that you repeatedly mentioned how client side of Kafka is super important, right? And all the heavy lifting is done by the client side actually. I think we'd love to have you for another dedicated session. And I think there we can specifically focus on how you can instrument the client side, and what are the things to track for the client side, what are sort of the challenges basically people face when it comes to monitoring the client side. Because again, you mentioned, right, client side is the one that is doing the main job, right? But I think overall it's important to track both the client side and server side, right, for the
Yeah.
overall performance and stability of Kafka, right? I know we are a bit ahead of time, but I'm having too much fun, to be honest. We have around 17 people who are watching till now, which is amazing. So for people who are watching, if you have any questions, let us know, because we are just about to wrap up. So Shrimal, just before we wrap up, right, I had one other topic which I wanted to definitely touch upon right before we end this one. So I remember you also mentioned about replication, right? You mentioned some other metrics, and in that there was you talked about replication, right? And one thing this that stands out with Kafka is how it handles fault tolerance through replication,
Mhm.
right? So, and that means that even if a broker goes down, the system can still keep on running, right? So but I'm guessing that when this happens, it also adds some overhead depending on how it's configured. right? So can you maybe touch upon this topic in brief, like how replication works and what teams should keep in mind when deciding that replication factor in production?
Yeah. I mean, like replication, that's something which protects us from, mm, uh, let's say like one broker goes down, and but we have to plan for that, right? Because I mean, failures can happen. We have to plan for failures. So we have to plan what will happen if a broker or a couple of brokers goes down. So that's where replication comes into the scene, because like what we do is that like we configure the replication factor. It should be greater than one. So like if we have five broker cluster with five brokers, we can have a replication factor up to 5. Uh, so that means like we are going to keep 5 copies of the same partition. So replication works in the partition level, um, and like we need to keep at least like a replication factor, the minimum number would be 3. Like we have to plan, like we have 5 brokers, 2 can go down, like if you have a replication factor 3, we have one more copy available to serve. So we have to plan it in that way. And replication factor increases the I'd say increases the cost, like because uh, uh, the more and more replicas we have, the more and more data we need to transfer in between brokers. So especially like when we have brokers, I mean, um, like cross-zone Kafka clusters, that becomes a real headache, because we have one replica in one zone, we have other replica in some other zone. So cross-zone network transfers, incurs more cost. We have to plan for those scenarios as well. Like if you need if you need more reliability, uh, we may have to run it cross zone. But if we run it cross zone, we need to think about like how should we assign partitions. Maybe we can run those consumers in the same zone. We can run those producers in the same zone. Like that assignment decisions has to be taken and can be automated too, because Kafka supports the configuration, it can keep a track of the rack that is being used to deploy. So that support, like that config options are available in Kafka. What we need to do is just make a bit more attention to details, and take that config right. So that's why I said initially, the first challenge is getting the config right.
Yeah, that makes total sense. And this is super insightful. Specifically, the last one which you mentioned, right? If you have brokers spread across zones, so that could I mean that could provide that stability you need, but it also impacts your cost as well at the same time, right?
Yeah, it is overhead. It's an overhead. Yeah,
Yeah,
it's an overhead.
definitely. And I think I think there is a lot to explore about Kafka, to be honest. I've just started doing so, right? And all the points that you mentioned, Shrimal, and some of the things, Isha, you mentioned when you were instrumenting Kafka were really super, super insightful. So thank you so much for both of you for taking all the time today. We are way over time for our chat, but I hope that people had fun. We still have around 20 people watching, which is amazing. So I hope we were able to provide you some insights on Kafka monitoring. We went from instrumenting Kafka, what exactly is Apache Kafka. We then saw what are the different ways you can instrument Kafka using OpenTelemetry, using the receiver, hotel receivers, right? And then the conversation with Shrimal was a gold mine, to be honest. I would say I definitely learned a lot from today's conversation, Shrimal. Thank you so much for sharing, and thank you, Isha, for sharing your experience with Kafka that you have been working on. Uh, to the topic of the top metrics, right? Because me and Shrimal had a discussion on that. So I'll just share a quick blog post that Isha has recently written on this particular topic. You can definitely check it out. And this basically covers what are the different categories of metrics that to look for, and what are the top metrics in those categories that you can look for in production for Kafka. I think this can be really helpful. And I think, Shrimal, we can have another session in the future to specifically focus on the client side of Kafka, right? Because you mentioned, right, that's really important too. But I hope you both had fun today as well, right? And I would love to see both of you in another episode. Do you have any closing remarks from your side, Shrimal? Do you have anything to share with everyone who's watching till now?
Oh, I mean, maybe like we can show a couple of dashboards, Kunal, like just to give them an idea, like what would it look like uh, in a real production cluster, uh, like a couple of metric dashboards. So yeah.
Sure. Yeah. I mean, I would say let's just share it. I think we can briefly touch upon that, Shrimal. I think because we are a bit over time. So if it's okay with you, maybe you can walk
Yeah,
us
yeah.
through really quickly, right? If it's all right with you. Okay.
So yeah, I
Thank you.
Guys,
mean,
Yes,
we
Isha.
also got the matrices actually. So if we gonna have some time, like I'll share the stuff that I was going to do that. If we have time, no worries.
Sure. Sure, Isha.
yeah. So let me go through this quickly. Like this is a dashboard we have for one of our production clusters, and like we can see, like all those important metrics here, like number of unreplicated partitions, and number of offline partitions, and like the disk space and some JVM metrics as well. Most of the stuff that you see in the dashboard are like somewhat critical to the cluster. And this is the server side, and this is the consumer side. So this dashboard is for one of our consumer services. Like it shows you, like consumer status, if it's, like join the group and like consume messages. So then the status shows as running, and like we do have message process latencies, and like some details about assigned partitions, and uh, the message distributions, like bunch of metrics here. This visibility is quite important when we, like run Kafka based applications in production. uh, yeah, so that's it, Kunal. That's it.
This is amazing. Yeah. And I just, because we are talking about visualizations, right? I just want to mention that we are working on some interesting custom dashboards at Randoli, which will be added soon. Specifically, if you wish to monitor Kafka in production, Kafka, Postgres, Redis, these major databases. If you are using any of those, the team is currently working on adding these dashboards, so that will be pretty out soon. And we would love to show you. If you want to learn more about this, you can definitely reach out to me, and we can explore your particular use case together. But thank you so much for sharing this, Shrimal. Uh, I'm really sorry. I think we are just way over time today. So, Isha, for your visualization, maybe we can show that in another session if it's okay with you, right? But thank you so much for both of your time today, sharing your insights. And I hope the audience had fun, and I hope we were able to, share some insightful information with all of you. Yeah, we'll see you all in episode 3. Bye. Thank you so much, everyone. Bye bye.
Thank you.
Thank you so much, Andy. All right,
See you again.
bye.
Yeah, bye bye.
See you.